Hi, my name is Jonathan Wise. I'm the VP of Technology at CESMII, the Smart Manufacturing Institute. Today, I get to provide an update on one of our efforts with the OPC Foundation and some of its key members. But before I do, just a few words about our organization. CESMII is one of the Manufacturing USA institutes that were created to improve US competitiveness in manufacturing and help accelerate important ideas in this space globally. CESMII is funded by the US federal government and was kicked off in 2017. We're a public-private partnership delivering over 140 million in investment over 5 years. We use that funding as the voice of manufacturing. We're not a vendor. We don't have a product to sell. We engage the ecosystem through a membership model and fund projects that as an organization, we determine will advance the state of the art in US manufacturing. Our overarching goal is to accelerate the democratization of smart manufacturing. Our strategy towards that goal is to direct our funding in 3 main areas. Technology projects aim to decrease the cost and complexity of adopting smart manufacturing concepts by identifying reusable patterns and scalable technology that can support all manufacturers from small to large. We advocate for and invest in approaches that are interoperable and standards-based and create real tangible value for manufacturers to improve their decision-making, throughput, and efficiency. Our knowledge investments aim to enhance the manufacturing workforce, empowering a data-driven culture and a smart ecosystem that harnesses both OT and IT technology. We do this through hands-on training, curriculum development, and partnerships with academia. And finally, our innovation projects advance the state of the art. They encompass new research that accelerates the adoption of new technology in an open and interoperable fashion, going after some of the toughest problems in manufacturing with an approach that is free of vendor lock-in or expensive infrastructure projects. In going after some of these challenges, especially as we maintain a focus on repeatability and reusability, we have the opportunity to engage with some industry thought leaders. Our decisions are based on input from CESMII members, and we bring that input to other organizations with similar goals. In 2020, while working with the Microsoft and OPC Foundation, we identified a missing piece in the OPC UA stack that we wanted to address, and we were excited about the level of enthusiasm we were met with when we brought it up. So together we kicked off a joint working group to build a rather unique companion specification for OPC UA. You can see from the list of participants, we're not the only ones with this pain point. The team is made up of some of the most influential thought leaders in our space, and as you can imagine, our working group meetings are lively and full of interesting discussion. As a group, we focus that discussion on something we call the Cloud Library. The Cloud Library is a repository of reusable UA information models, and it supports a wide variety of use cases, and I'll talk through a few of them today. In the first set of scenarios, we imagine information models being useful independent of a running server. This could be because the machine that serves the data hasn't been commissioned yet, or it may be that the machine has been commissioned and it's been shipped to a customer or deployed remotely in a location with only intermittent connectivity. In these situations, the information model acts as a proxy for the machine or system, allowing applications to understand the structure of the data in the abstract and providing a point of reference to interact with for pre or post commissioning situations. In the second set of use cases, we imagine a machine that is being built or commissioned, and the implementer needs to validate what they're building against some point of reference. In some cases, there may be a formal reference specification to work against, but in many cases, systems can be very ad hoc, or standards may not exist or may still be evolving. Being able to look up a reference information model provides an approach to validation that supports both human and programmatic evaluation. The third set of scenarios is similar, except instead of building a machine, we might be building an app. The app developer needs to create an information model that their app will work around. Rather than starting from scratch, they can search a central repository to find what models already exist and then derive from, extend, or even directly apply those models to the tool they're building. The final scenario I'll talk about today is one that CESMII is particularly passionate about. Here in the US, the vast majority of our manufacturing runs on existing infrastructure. Manufacturers want to take advantage of modern technology like OPC UA, but they don't want to rip and replace their existing systems. a repository of information models for common equipment and processes can provide a map that we can bind those systems to. It abstracts the brownfield system into a more modern information interface by pulling from a repository of things that have already been published. Of course, we can solve all of these problems today. We can do it with or without a UA information model, but having a common language and a central location to publish to or search within accelerates implementations. It keeps us from having to reinvent the wheel over and over again every time we find a system we've seen before, or resorting to less than optimal approaches to building and sharing information models. I got permission from one of the working group members to illustrate a great way to tackle this today. Here I'm showing a model design tool called UMX Pro from an outfit called Beeond. And I'm looking at a blank slate, or almost a blank slate. Like with any UA project, I never have to start from nothing. I have the base namespace and all the constructs that exist within it. But in this scenario, imagine I have a robot that I want to model. And robots aren't part of UA namespace 0. So I'd like to know if there are any standards or implementations already out there for robots, so I don't have to invent the model myself. So I'm going to head to Google and I'm going to search to see what's out there. And in this case, I'm going to get really lucky. An organization called VDMA has expertly defined a robot information model. They've developed a UA companion spec for it, and then they've published that as a portable node set file, which fortunately the OPC Foundation has made available on their GitHub. So I've got everything I need. I can download this model, I can import it into UMX Pro, and I can benefit from the work that others have done. Unfortunately, this idealized scenario only works for a small number of situations. There's only a few of these published. Building a companion spec is not a simple task. And the list of available node sets is pretty small given the size of our industry. It's not fair to interpret our goal as building a GitHub for node sets, but there is some of that crowdsourced, innovative open source juice that we want to enable with the Cloud Library. So the Cloud Library Companion Spec addresses this scenario and the other use cases I described. For this diagram, I've chosen to describe any person or code that wants to find information models as a consumer generically, only because the word client has another meaning. A consumer can be an OPC UA client. It could also be an OPC UA server, or it could be literally anything that can make a REST call that would benefit from a repository of pre-built information models. That's because these UA information models truly are portable and they can be used anywhere. It doesn't necessarily have to be within a UA ecosystem. Sheffield University's Advanced Manufacturing Research Center recently demonstrated how you can leverage UA information models as the foundation for their Factory Plus system that uses MQTT as the underlying comms protocol. So we can use these things anywhere if we had a place to go find them. Regardless of who or what this consumer is, the Cloud Library supports them by exposing a REST-style API with a few interfaces. These interfaces support searching for information models, including like a fuzzy search where I don't know exactly what I'm looking for, but I want to look at the model metadata. It's going to support commerce. So there's the possibility that you may want to monetize information models you've built. It supports downloading a node space or an address space once you've found it, and uploading an address space that you've created that you want to share with others. And then it optionally supports that validation scenario where I have an information model and I want to validate what I have on board against some reference point. If we project forward a little what this might look like in the future, I took some liberties and mocked up how it might be integrated into a tool like UMX Pro to seamlessly engage information modelers in that tool with a community that has published models for reuse. At CESMII, we're imagining not just large-scale comprehensive models like VDMA has built, but also smaller reusable component models that can provide information interfaces for subsets of data like energy analysis that could work across a wide range of otherwise dissimilar machines and systems. Microsoft's imagining using the Cloud Library across their IoT ecosystem. accelerating the instantiation of asset UA servers that can quickly identify themselves against published information models and auto-configure data flow, analysis, and actions in Azure. And CESMII members are bringing their own software technology and contributing to an open platform that embraces information models across the stack, not just for instantiating objects that are strongly typed against a reference, but also these information models become the API for app development. And through an extension we're working on, also become a mechanism for binding object instances to other protocols. Finally, making it easy to leverage apps independent of a particular vendor ecosystem or platform. We call those combined uses of an evolved UA node set the Smart Manufacturing Profile. And we're actively funding tools to simplify the creation, reuse, and application of these profiles across our smart manufacturing projects. I'm happy to share that we plan to be one of the first to implement the cloud library specification that we're working on and making it available as a resource for the manufacturing community. So if that's the vision, today my job is to report on our current progress towards it. Last month, our initial draft of our companion spec was presented to the OPC Foundation's Technical Control Board and accepted as a release candidate with a few follow-up actions that the team is taking to address their input. 3 members of the joint working group have signed up to do prototype development with the support of the OPC Foundation. My team at CESMII, Microsoft, and INRAE will be doing the bulk of the development for these prototypes, but with guidance and input from the broader group. And together we'll iterate on exactly what the API payload responses look like, so we can document that, and then making some other improvements to the specification. We're really excited about the progress we've made in a relatively short amount of time, and we're pushing towards an initial availability later this year. If all this makes sense to you, or if you have other ideas for how to help the industry embrace openness and reusability, or if you just have a passion for seeing manufacturing get smarter and more efficient, we'd love it if you'd engage with us at CESMII, with our counterparts of the Industry 4.0 team in Europe, or with other groups that are pushing the industry forward. CESMII membership is made up of manufacturers, software developers, researchers, system integrators, and academics, and we're leveraging our resources and funds to accelerate their efforts. We want to push forward the best ideas in the industry and bring together different perspectives and technologies for better interoperability. You can learn more about CESMII on our website and about some of the technology we're building and advocating for on our GitHub page. Thanks.